All right, how is everyone? Tonight's probably going to be a short stream. I got to get to working on my video, but I'm actually going to record a video or a section of it. So I basically have my next Rust video done, but what am I doing? Nothing good. Nothing good. The garbage. One second, my layout has gone all bonkers on me. Well, that is no help at all. All right. Well, we're just gonna leave it at that. We're gonna leave it at that. Okay. So what am I going to do? I'm going to record just a little. Because yeah, I need to do my Rust things, and I think I can do it. The only thing that's weird is I don't generally have this because my camera has a microphone. Um, so I didn't really think about that. Maybe I can push this a little out of the way. Can you still hear me? Not nearly as well. Not nearly as well. Well, we'll try to just get it right there. That will be good. That will be good. All right. Well, then. Let me go get my camera starting to record. I got to go physically press that button. And then we'll get this recording out of the way. And then we'll get back to the regularly scheduled program. Okay, I'll go start the recording now. Well, that's a really interesting feature. You guys got to see my camera menu while it's outputting. That was really weird. Who knew that was a feature? Okay, so I'm going to record really quickly. This should take only a little bit. You're more than welcome to stick around. I'm not going to pay attention to chat during this, though. This is for a video. And yeah, and then we'll get on to some programming after that. Just our regular stuff. Cool beans. Hey everyone. Okay, so we have been doing. Well, that was not very good impromptu. My goodness. You guys get to see a little as goes on behind the making of these. I usually, well, it depends. Some have scripts, some don't have scripts. The educational ones usually actually don't have scripts. I do have like key talking points. But yeah, this part I don't have a script specifically for this part, so I just have some talking points to talk about and to type out code. All right, so in our last episode, we learned about flow control, and today we are going to learn about kind of the next evolution of flow control, which is errors and optionals. How do you return an optional value, and how do you return something that could have error information? It's important to not just send an optional, because with an error, you're able to return information and allow people to act on that. So we're going to learn about both of those today that are going to empower our flow control in Rust. Now, I recorded this video in 2 steps, so you'll see me changing some clothes in between. So in this second little bit here, we're going to talk about results. I had to re-record it because originally I recorded it and I didn't explain some things that I thought were really important. So let's go ahead and jump over into the code. Let me make sure this is recording. There we go. All right, so as you can see here, I actually made a couple functions without you all. We have a might fail that could possibly fail, a might fail that returns a string, and but you know what? I want to focus on these. Now, all of this code is checked in, so you're more than welcome to go and check out those bits of code and use them. So you can play around with them and use them. They're things that might fail or might not fail. I'm kind of simulating some error cases there. All right, so what do we have here? We have these 2 functions to get user input. And I just want to use this one first. This one actually is handling an error for us, and this one's not. This is actually the better way of doing it, but let's jump in and actually use this first one and handle an error ourselves. So we're going to let result equals, let me turn off AWS Code Catalyst. I just want to turn it off. It was working. It was showing me stuff. I don't want it to. Okay. Let me retype. Okay. So let our result okay. So let user return equal this function. Now what this function is doing is getting input from the CLI, the command line, and it's going to pause the terminal and wait for it. You can look through this. This is just using some functions we used the last time for flow control, just to get some input, and it's asking the person for a number. So, but it's actually a string, and we'd like it to be a number. So there's a pretty easy way to do this. This doesn't really matter a whole lot. So we can let trim input equals user return dot trim dot toString. This isn't about this. All this trim is doing is removing that extra return character, because if you remember right, in the command line, if you type in the number 3 and then hit enter, enter is part of that string, and we're just trimming off that white space. All right, now we want to actually parse this as an integer. So we can say let input as int equal the trim input dot parse, and here we want to tell it to be an integer, so we can do what's called a turbofish as an i32. All right, so here we have this input, and it's trimmed and parsed as an i32. But you know what the crazy thing about users is they might not give you an i32. Let's print this out and see what I mean. So again, we're just gonna print out our int that we've gotten, and we'll see how this works. So let's run this. There's an error. Why? Wait. What? Oh no. This was on purpose. All right. Perfect. As planned. This is erroring because it doesn't implement display. And the reason it doesn't implement the display is it's not actually an integer. It's a result of i32 or a parseInt error, meaning this function here, this parse, can return a parseInt error. So we have to unwrap this. Now, we can do the thing that I've told you never to do and basically just call unwrap on this, and this would work. It stops erroring. But that's not what we want to do. We want to handle this properly. You can handle these just like you do optionals. So we learned about optionals, and you remember that we use these keywords some and none. The only difference with results is you use okay and none. So let's do that now. So let's use a let statement. Let okay I equal input as int, else turn error. Is it not going to let me do this? Okay, yeah, it's not going to let me do this. We'll do, what would be the easiest thing to do here? We'll just return okay for right now. All right, we'll return our own error in just a little bit. I'm going to show you how to make your own error and return some useful information. All right, so now we have this variable I, just like we did with an optional, that we can use here. Remember, we cannot use I inside of these bounds because this is the else statement, and this statement actually has to diverge. You have to call return. If we don't call return here, and there's no branching logic, Rust will get angry at us. It is an else cause, and it's trying to have try adding a diverging expression. It needs a fork in logic because I cannot exist in here, and it has to exist. It's guaranteed to exist with all the code that happens after it. Pretty cool. All right, so what have we done here? Let's run this and see. Let's run this and see. We run it. It asks us to pick a number. Let's pick a number 2. And this works. I is 2. That's fantastic. All right, but I wanted to point out again, this is just the same. It's okay or error. So instead of doing it like this, let's use a match statement. So we'll just do match input as int. And then we can do, we can match on OK. And on OK, we want to print. And then the other error case is error. And this is a parse int error. You can just do an underscore if you don't want to care about the error. That's a little lazy, but that's what we're going to do right now. We don't care. Print line. I said number, you fool. A little passive aggressive. Maybe that's actually not passive aggressive. Straight aggressive. Okay, so let's run this and give not a number to just see this work. All right, so we're running. It says pick a number. I'm going to put my name. And we can see we have the other branch. We've effectively dealt with an error, but we've been forced to. We've been protected from using I unless if it meets our requirements. Rust makes dealing with errors kind of the default, but it gets a little bit better. So let's dig into this a little bit better. And guess what? Originally, when we were looking at this, I told you that this was a better way to write this function, this right here. It's better to write it like this. And what this does is it returns the error. Instead of dealing with it here and consuming an error from reading the line from the user, it returns it to whatever was using this function to get an input. Now, I don't usually put the name result on there. It just was differentiating it from this one. But that's what it's doing. And this is much better usually. Now, sometimes you're at the top level of your application. You need to deal with the error. And that's great. But a lot of the times, things like this, the best thing to do is just to bubble that error up. Okay, but it gets even better. If you notice, I have another one here, and I wanted to show you this one. This function is called getInputAsInteger, and basically it does everything that we did above. But I wanted to show you one unique thing about Rust, because I know some of you are thinking that the syntax is getting a little bit verbose. So if you have to catch every single error like this, and all you want to do is bubble that error up, this is a lot of typing just to return the error, because you could get the error in E here and you could return the error. You could do this right here, return error. And we'd have to box it here. Anyways, we're not doing that right now. Let's just get our print line there. The reason we're not doing that is because, anyhow, that's something that we could do, but what I want to show you right now is that you can actually just propagate errors automatically. This is pretty cool. So this right here does a couple things. It first uses our function here to get the result. And you'll notice this question mark. What this does is propagate your errors. So this is propagated as a box dynamic error. So if you're wondering what this box is here, if you're wondering what this is, std error is the error trait. If you go look at this, it is a trait, which is an interface for all intents and purposes, which means it's not an actual implementation. And because it's not an implementation, then it means that it doesn't have a fixed size, and Rust wants to know the size for memory. So what box does is it boxes it in a very known size and has a reference to this error thing inside of that. So there's a known size to this unknown size thing. So that's all box is doing here. And dynamic is just saying, I know that this is a trait. That's all it's saying. This is saying, I know this is a trait, and this is wrapping it in box. That's it. Simple and easy. All right, so what this is doing here is you can see that this get input result actually returns a result, but we're using the usize directly. We're not calling unwrap. We're not doing anything like that. We are not doing a match. We are using it as a usize, what it returns directly. And the reason we can do that directly is because we are doing this question mark, which basically unwraps, and on failure, it propagates, it returns as an error. So it basically does that match statement for you and does a return. Super powerful. And so you can see that we use that throughout this. We first unwrap the result. We then call to string on it. We make a string. And then we parse that string as an I32. And you don't have a ton of match cases. Throughout this, we are propagating this error up throughout this. That's super powerful. This question mark means you can do what we just did above without all of that typing. You put a question mark on it, and as long as this is returning a result, as long as your function is returning a result, you can do that. Now, if we delete this, you'll see that we get errors now because it's not able to propagate that error, and that's what it's trying to do. All right, cool. So we want to create our own error type. We want to create our own error type here. So we're erroring here, and we want to return our own error because that's just something we want to do. Okay, how do we do that? Well, you can make your own error type. Any type can. We saw that error was just a trait, and that means that traits can just be implemented. So let's make our own right now. Let me check my notes really quickly, making sure I'm hitting all my notes. Do you guys think I should have more examples? I feel like no, because we did it all with optionals anyhow, but let me know. Nailed those. Okay. I am going to type these out. All right, so let's type these out really quickly. I'll explain at a high level what I'm doing as I do it, and we'll have our own error type at the end. So first we're going to derive debug on this. This is implementing a debug trait so that we can print this out. You don't have to do this, but it's really convenient if your class can be derived. This is basically auto-trading something. All right, so we want a struct bad input error. And this bad input error is going to have some details on the error. of type string. Cool. Now, for this, we are going to have a really easy. We're going to make a function to allow us to create a new one really easily. So let's do that. All right, and we're just returning one with the details as a string. Pretty easy stuff. All right, the next thing that we need to do is implement a display. That is something that is required for errors, so we'll do that now. Impl this it's under FMT display for bad input error. So display has a FMT function, so that's the one that we need to implement. And you'll learn more about this if this is a little confusing. We're going to cover this more in detail in just a little bit. This is just letting you create your own error. It's a little boilerplatey, but it's not too bad, and it's very powerful. Now, I don't actually find myself creating my own errors for a lot of things, so I don't think that you do this a whole lot. But just keep in mind, you can use a struct or an enum. I know that I keep talking about enums. We're going to learn more about enums soon. Yeah, for all of you watching in real time, I cut out all this typing. All right. Beautiful. And the last thing that we need to do is we need to implement error, that error trait that we saw. So there is only one function that you must implement for this, and that is the description. So let's get that done. And this is it. We've created our own error, our bad input error. This is pretty awesome, and it allows you to return some stuff. Again, I really like using enums and we're going to use some more enums in a second. But let's go ahead and use our new bad input error in our code above. So you remember here we return this underscore. That's not really what we want to do. We want to return a bad input error. So we can capture E like this. So now we're actually capturing the error, but actually we don't need the error. We don't really care. We know that they didn't put in a number. Everybody knows that. It was a bad parse end. So what we really want to do is return our new error. So let's do that. All right. So let's see. What did I mess up? What did I mess up? Oh, so we're just boxing. This is just the box, but we have to return a result. And this is of the error type. So all the other places you've seen, we've returned okay. And you can return okay with a value, as we have previously. Oh, I made this function and didn't even use it. It's such a nice helper function method. All right. So we are returning the error type. We're propagating that forward instead of the okay. So here we go. We have created our own error. We have used it in flow control, and we've learned to leverage a little bit about flow control. Thanks all. And please stick with us as we continue learning more about Rust. I hope you enjoyed this, and I look forward to seeing you guys next time. Whew. Okay. Let me stop everything recording. Stop recording there. I gotta jump around and tell the camera to stop, and then we'll get on to stuff. All right. All right. Let's see. Oh, this is a little annoying. Let's get Copilot working again. I'm going to have to cone of silence, you guys. Cone of silence. All right, auto suggestion. Back on. We're back online. This battle station is fully operational. Okay, this is garbage, 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 garbage. Let's open up. I don't know. I still don't like that segment, to be honest. I'm struggling doing it fast enough while also covering as much information as I want to. And I think I feel like I keep throwing away information that's valuable, but I also need to be comfortable with, hey, they're not going to understand everything. And you'll cover that more as you get into some of the projects, because I want to work people through some smaller projects. So yeah, anyways, let's see. We need to Twitch alerts. I know exactly what we're doing today on this. We are making the API. We're making 2 new projects. We probably want to start in the terminal. Probably. Let's see. We want to go to the Twitch alert. Okay, so now we want to do cargo new. What do we want to call the front end API? We have 2 things to make here. We have a user service and a front end API. What do we want to call them? I'm going to just do this lame. Front end API. I'm doing dashes, not. No, I'm doing underscores. API. And then we're also going to do User service. All right, now let's update our workspace. Cargo should have added it to our workspace, but it's okay. I'll forgive it. We're gonna call this front. We already did front end API, and then let's see. We did user service. Now, I actually think we should stick with a naming convention here because this is actually going to maybe help us in the... Why did you fail on me? Oh, because I mistyped this. There. Stop failing. I actually think that maybe this is how we define what gets built when you build. I hate putting magic in... naming, but we might have to do something like that. Like an API gets added to the service mesh, whereas the AI manager service doesn't. A service is just an internal service. An API is added to the external. We might... Now, we could also do it with like a configuration file so that like you have to have a null cloud configuration file. I don't know what people would like. Would they prefer magic with names or... Yeah, I don't know. I really don't. Or more YAML files. Like what that's your choice. That's your choice. It's not fully your choice. I've been thinking about it because we could do stuff where like we have you derive stuff on the API objects. We could. Then it's in code. But then the problem is it's a lot different for each language because you don't have these drive things for we don't have these drive macros for things like Go. And so then the Go implementation of this is vastly different. And I know if there's a backend API that handles all that, it's fine. But is it fine? I feel like having it as close to the same is important. So we'll think on that still. All right, so we have... This is how we did this. We put these in common, basically. I'm starting to think this was a mistake. I generally think that if you have a common, it's a mistake. And so I'm going to try to do this next one without common. The AI manager is going to define its message that it will send. Am I about done here? I am about done here, yeah. I have a video that I need to finish editing. I'm not sure if what I recorded was any good. Let's go ahead and just make the AI manager. So the only thing I was thinking is I almost think that the user service should be the one that defines the message. I'm going to actually do that. You don't want to hear my... Yeah, I do want to hear you. What was your opinion? Let's see. So what are we sending? We're sending a message when we get... So basically what we're trying to do here is define our streams. So you could almost think of this as a stream. So we're going to say that this stream is called... new... Actually, is this the same message? No, it's not. Because it has like the new... we'll say display. Oh wait, why are we on the user service? Oh no. We're on the... I meant the front end API? No. Completely different service? Yes, move that. Let's see. Pub. Do we want to do it like we did? I think we do. If we're talking about this one, where there can be multiple different types, I think this is the right idea here. I'm just gonna copy and paste this actually. That will be fast. Boom. And then we'll do Twitch event here. Do we want all the same stuff? I'm tempted to code share, but that's also usually... It's probably display event. Yeah, this is actually probably better. Display event is probably better than Twitch event. We'll... Do we need the message ID and message at? I actually think we don't. Because we're using that to protect against replay attacks, but we shouldn't have replay attacks here. This should all be internal at this point. Just service to service. And this is pretty much the same, except here we have pub. Do we need channel name? I don't think we do. We don't need any of this stuff, actually. This is just for the display. So if this is just for the display, we need a story segment. And right now, all we have is a story segment. We should have like a URI for an image, but we don't have one of those yet. Oh, we'll put that in here. There's probably a better type for that as well. I don't know. All right. Let's, while we're at it, make another event. This is a follow event. We want a subscribe event. I think they have actually the same things for right now, but it allows us to differentiate if in the future we want to. And there we go. All right. And I think then we can also do a nice little derived debug right here on the new display. All right, so now we have the front end API defining the message that it wants to get. Now, the only problem we have when we're talking about dependency is that means that anything that wants to send a message to it needs to depend on it. This is where I was doing the common as just a message. Now I've seen this done in Go with protobufers, is have like a central API. Maybe that's what we want to do. If everything that I'm doing right now seems wrong, it's because we're developing a brand new way of developing. Brand new. Absolutely brand new. So there's a lot to think about. We're doing the microservice, but no microservice architecture here. There is this should hopefully be able to run as a single and as multiple things, as a microservice and not locally. So there's quite a bit of like, how do we want to actually do that? And some of this is going to have to come down to like, let's actually do it and then figure out how that sucked. I'm trying to also limit dependencies on each other. Now, messages, maybe those should all be in common. I'm going to pull an audible, and I usually then disagree with this, and I get really upset with myself. But I'm going to dump all of these in common for right now. And maybe we change common to messages. Maybe that's what we do. I actually like that because so far that's all it's actually there for. And when we get back to that, like the name has meaning in this deployment style, maybe this is what it is. Actually, we don't need to go there. All we need to do is go here, and instead of common, call this messages. Sounds stupid. Communication sounds stupid. What do I call? I'm going to call it messages. Oh, no, I know that there's got to be a better, there's a standard way of saying this. Why am I blanking? I can't even think of the term to search. There we go. I pulled it. We're calling it messages. I'm at the stage of I want to get stuff done instead of I want it to be pretty. We can change its name later. That's what we can do. All right, in that case, we also need to start changing some of these. This is the user service. Kafka's going away, I think, entirely. I think we want to generate that. But that being said, we probably will have to create it by hand first so that we can write the generation code for it second. So we'll leave it there because we'll probably have to do that. Messages is here. Twitch listener is a service. Done. AI manager service. Boom, boom, boom. Let's rename these. API, front end API. It's an API. Messages are the messages. User service. Wait. I had another one that we changed, right? Twitch listener service. Twitch listener service. Done. Why is Rust Analyzer still upset? Failed to load manifest common. You're right. We don't have common anymore. Ooh, I have screwed up our dependencies chains. Okay, let me fix that really quickly. Where's our debs? Not our debs. Not our debs. Okay, so what have we screwed up here? We have screwed up this right here. All of our dependencies. Not there, but here, where we depend on common, like here, there's now messages. AI Manager has the same problem. I did a bad thing. Renaming stuff kind of sucks after the fact. Failed to load AI Manager. That's right, you did. Twitch listener service. We're back to this one. AI Manager. It's now AI Manager service. Service. We're still failing. For AI Manager in Monolith. All right, this should be the last one. This should be the last one. AI Manager, Twitch listener. Here we go. Twitch listener service. Probably shouldn't depend on that, really. Up. We're not quite done. Twitch alerts monolith. Wait. Common also. Common got messages. Now this is going to cause problems in our code as soon as the manifests survive. All right. Kafka. Kafka, you don't even do anything. You don't even do anything. All right. This is what I was expecting. No, this is not quite what I was expecting. Let's go into messages. Let's go in here. Got to update all the names. This is gross that this is a lib and a listener. I forgot we had to do that. It should go to... All right. No matching package. Twitch listener service found by package monolith. Why are you failing here? Cargo watcher failed to command produce. Twitch listener service. You searched in the right place. You searched in the right place. Twitch listener service. This is the right place. Why does it not find it here? Twitch listener service. And they updated the bin and the library. I didn't, let's see. I didn't have to do this, did I? That would be dumb. Yeah. That would be dumb. This is just the path. Oh wait. Oh, this is good. This is the error I was expecting. It now is saying I need to be messages. Good. Beautiful. Oh, maybe I just need to work through these errors and it'll be. I might have just broken it. Oh, maybe I did. There we go. We're back on track. Good. This is what I was expecting. All right. Beautiful. Awesome. There we go. We're cooking on all cylinders. Let's push that and call it a night. Okay. All right, well, I think that's it for me tonight. I will see you guys Saturday morning.